Now we are discussing about progressive wave. What is progressive wave? The wave which is moving with energy, which is transmitting energy from one place to another place, is known as progressive waves, and its equation is given by y is equals to a sine omega t minus kx. For complete you can write phi for phase difference. What is omega? Omega is 2 pi by t. T is time period. What is k? K is 2 pi by lambda, known as wave number. Phi is phase difference. What is this x? X is displacement of wave. What is this y? Y is displacement of particle. We know that when waves are traveling in a medium particles are performing simple harmonic motion about their mean position. So displacement of these particles is denoted by y, and displacement of wave is x. Minus kx means wave is moving in the positive direction of x-axis If two waves of equal frequency traveling in same direction superimpose, what will be the resultant? You will get interference. What you will get? Interference. It means at some places intensity of sound will become very high. At some places it will become nearly zero. The places are known as silence zones. Places are silence zones. That are the places where amplitude of sound, if it is become A1 plus A2 whole square, these places are the places where the intensity of sound is maximum. Places where amplitude of resulting wave will become A1 minus A2. It will become A1 minus A2. These are the places of silence zones. These places are known as places of constructive interference, and these places are known as places of destructive interference. And we know that intensity depends upon amplitude square. So at these places intensity will be maximum, and loudness is the function of intensity. So loudness of sound will be maximum at these points and minimum at these points. But if two progressive waves of same frequency are moving in opposite direction superimpose, what you will get? You will get a stationary wave. In stationary waves, where particles are not allowed to oscillate, are known as nodes. These are the points of maximum pressure, and the points where particles are allowed to oscillate with maximum amplitude are known as antinodes. So in stationary waves you will find nodes, antinodes, nodes, antinodes, and distance between two nearby nodes is half of wavelength. Same for antinodes. The distance between nearby antinodes is again lambda by 2. It means distance between node and nearest antinode is lambda by 4. So you will get stationary wave. In this case, you will get stationary wave. And if two waves of nearly same frequency moving in same direction superimpose, you will feel waxing and waning of sound. Means you will hear beats, one high sound and low intensity sound you will get after a regular interval, and the beats frequency will be difference of frequency of two waves. But if they are not nearly same frequency, you will not hear beats. So beats frequency is the difference of frequency of parent waves. But if it is more than 10 to 12, this difference, then you will not hear beats. Regarding beats, one important point is there, that if you are sounding two tuning fork together and there is a difference between their frequency, you will hear beats. But when you will file the arm of this tuning fork, its frequency will increase. Its frequency will increase. But if you are putting some wax on this, loading this, then frequency will decrease. They can frame the problems based on this concept. Suppose I am saying you, I have one tuning fork whose frequency is known. It is 256 Hertz. I am sounding this tuning fork with another tuning fork of unknown frequency, but I am getting 4 beats per second. I am getting 4 beats per second. Now I put some wax on this known frequency tuning fork. Now I am getting 2 beats per second. What is that unknown frequency? So how to solve this type of problems? See, number of beats means difference between frequency. If initially we are hearing 4 beats per second, it means difference of these two frequency, this unknown and this known, it should be 4. So expected values of x are either 260 or 252. Because in mathematics, there are only two numbers which are at a distance 4 from 256. 256 is between them. Now what they are saying, कि when we put some wax on this known frequency, number of beats is decreasing because it is now 2 beats per second. So see, कि if this number will decrease, in these two numbers, which whom its difference will decrease, definitely when it will decrease, it will go near to this. If it will increase, it will go to this side. So it means it is moving towards this. So a known frequency should be 252. So a known frequency should be 252. So in this, remember about beats, interference, they can give problem on that. We will discuss problems, but first I am giving you some tips before starting the session of our 45 problems. Now, there are some problem related to sonometer. What is happening in sonometer? We are giving tension to one wire, and when we are sounding this wire, we are getting musical sound. So what is the frequency of this wire? We want to calculate this. You can fix your sonometer wire in so many ways. Suppose it is your wire and you fixed these two ends. Now when you stretch the wire from middle point, it will vibrate like this. It will vibrate in this way. You will get one node at this point, one node at this point. We know that distance between nearby nodes is lambda by 2. So you will hear a sound of wavelength lambda by 2. We know that V is equals to N lambda. If the length of sonometer wire is L, in this case L is equals to lambda by 2. So lambda will become 2L, but velocity of sound waves in a string is given by root T by M. And lambda is 2L. So what we are getting? We will get a sound of frequency 1 upon 2L, root over T by M. T is tension in this string and M is the mass per unit length of string. But if you fix your sonometer wire like this, you fixed at 2 points, see this and this, at A, B and C. Now it will vibrate like this. By making 2 loop, it will vibrate. Now your length of your sonometer wire, it is node, it is node, it is node. So lambda by 2 or lambda by 2. So now length of your wire is equals to 2 lambda by 2. So lambda will become 2L by 2, not cancelling 2 with 2. You will understand why. So now you will get a sound of frequency N is equals to V upon lambda, and V is T by M, and lambda is 2L by 2. So you will get 2 upon 2L. Just next frequency which you can get from this sonometer wire. But if you are fixing like this, fixing at 2 points, now vibrations are like this. It means now the length of your wire will vibrate like this: node, second node, third node, fourth node. Now L is equals to lambda by 2, 2 lambda by 2, 3 lambda by 2. So you will get a node of wavelength 2L by 3, 2L by 3. So it means you will get a sound of frequency N is equals to V upon lambda. V is root T by M and lambda is 2L by 3. Just next frequency of N1. So what you observe? We observe that if our wire is vibrating by making P loops, it will get a frequency P by 2L root T by M. The lowest frequency which you get from any instrument is known as its fundamental frequency. So in case of a string, fundamental frequency is 1 upon 2L under root T upon M. Remember always, in case of a string, fundamental frequency is 1 upon 2L under root T upon M. Just next higher frequency is known as second harmonic or first overtone. So first overtone of a string is 2 upon 2L under root T upon M. It is known as fundamental frequency. The lowest frequency which you are getting of any instrument is known as its fundamental frequency or first harmonic. Just next higher frequency is known as first overtone or second harmonic. So you can naming like this. It is pth harmonic or p minus 1th overtone. It was vibration of strings. Now we will discuss little about vibration of air column. What it was? It was vibrations of string. Now we will discuss little about vibrations of air column. To see the vibration of air column, I am taking one narrow tube. It is known as organ pipe. Organ pipe means a narrow tube in which freely air can go. If it is closed at one end, it is known as closed organ pipe. Closed organ pipe. Closed organ pipe. If it is open at both ends, it is known as open organ pipe. Open organ pipe. What is happening here? When if you are taking one tuning fork, after hitting on pad, you take it near to this. Due to vibration of this tuning fork, sound waves will generate and they will travel in this air column. After reflection from this closed end, they will come back. When they are reflecting from closed end, there is a phase change of pi. Phase change of pi. Mean in place of node you will get antinode. In place of means where are sound waves are traveling in the form of compression and rarefaction. At the place of compression you will get rarefaction. At place of rarefaction you will get compressions. So we will say phase change of 180 degree. So after superimposition of these two waves, one is going in this direction, one in this direction, you will get one stationary wave. And the primary case is this, you will get one node at this point and one antinode at this point. Antinode where particles are free to vibrate, and where they are not free to vibrate, we are getting node. It means the length of air column is divided between this antinode and node, and this distance should be lambda by 4. I told you distance between nearest antinode and node is lambda by 4. So if length of tube is L, we can say L is equals to lambda by 4. But V is equals to n lambda. So therefore n is equals to V upon lambda. What is lambda? 4L. What is second case? Second case is this, कि in your organ pipe, maybe at open end always antinode and close end always node. Maybe there is one more pair of antinode and node is there. After antinode node, after node antinode. So means like this. Maybe like this. Between one antinode and node, maybe there is one more antinode and node. Like this. Means in this case, just next case, length should be equal to 1 lambda by 4, 2 lambda by 4, 3 lambda by 4. It is 3 lambda by 4. So what we will get? L is equals to 3 lambda by 4, means lambda is 4L by 3. So you will get a note of frequency n is equals to V by lambda. Lambda means 4L by 3. Similarly, in next case, you will get 5V by 4L. So what we will say? In closed organ pipe, we will get a fundamental frequency of V upon 4L. And first overtone is 3 times the fundamental frequency. And second overtone is 5 times the fundamental frequency. So what frequency we are getting are in the ratio 1:3:5. So what we will say? Ki we are getting only odd harmonics, only odd harmonics. But what will happen in case of open organ pipe? If you have one open organ pipe, open end always antinode. So minimum one antinode here, one antinode here, between them one node should be there. Means case is like this. So length of air column is determined by lambda by 4, lambda by 4. 2 lambda by 4 means lambda by 2. So what we get? N is equals to, means lambda by 2 is L. So lambda is equals to 2L. So you will get N is equals to V by 2L. The fundamental frequency of open organ pipe. What is the next case? In next case, we got one note. Next, it should be 2 notes maybe. We will get 2 notes between this antinode and this antinode. You will get 2 nodes, means antinode, node, antinode, node. Just next case means which type of this? Open organ pipe. So now its length, it should be equal to 1 lambda by 4, 2 lambda by 4, 3 lambda by 4, 4 lambda by 4. So now 4 lambda by 4 is equals to L. So what we are getting? Lambda is equals to L. So frequency you will get V upon L, multiply and divide by 2. So we are getting this. So first V by 2L, then 2V by 2L. In next you will get 3V by 2L. After that you will get 4V by 2L. So what we are saying, कि in open organ pipe you will get frequencies which should be in the ratio of 1:2:3:4, means you will get all harmonics, It was vibrations of air column. After vibration of air column, one important concept is remaining, that is Doppler's effect. Not very tough and very big. What is happening in Doppler's effect? When you are moving towards a source of sound, you will feel that frequency of sound is increasing. Suppose a car which is sounding a horn, it's going away from you. You will feel that frequency of sound is in decreasing mode. So this apparent change, actually it is constant, but due to motion of you or motion of source, you are feeling that frequency is changing. So this apparent change of frequency due to motion of source or observer or both, you will get a decreased or increased frequency. This effect is known as Doppler's effect. So learn only one formula which I am giving you for this. Suppose it is observer, means you, and it is source of sound. Both are moving towards each other. For this case, I make this formula. Speed of observer was VO, speed of sound was Vs, and medium between observer and source, you know that sound cannot travel without medium, but if medium is also moving, it means velocity of sound will increase or decrease. So medium means wind is blowing with velocity W at an angle theta with the speed of sound, at an angle theta with speed of sound, and speed of sound is V. So what frequency you will get? You will get a note of frequency V plus VO plus W cos theta divided by V minus Vs plus W cos theta. It means if you want to apply this formula in your numerical, there is nothing given about wind. Forget that, means W is 0. So your formula is now V plus VO upon V minus Vs. If observer is stationary, put in place of VO 0. If source is stationary, put in place of source 0. If any one of them is moving away, they are not moving towards each other, then change the sign of velocity. Means case is this: observer is moving towards source, but source is moving away from observer. So what change you have to make before solving your numerical? In our this formula derivation, we assume that both are moving towards each other. Observer is on right track, he is moving towards source. So VO take sign as it is, but Vs, source, is moving away from observer. So change the sign of Vs. So formula will become, in this case, you will get a frequency V plus VO upon, change the sign of Vs, V plus Vs into actual frequency. And in case of stars, we are also seeing, we can observe the Doppler effect in light, but there is only one formula. Star is coming towards you or going away from you. The change in wavelength, you will get lambda V divided by C. Lambda is actual wavelength of light emitted by the star. V is its velocity and C is the speed of light. What change you will get? You will get by this formula only. So it was the complete theory which you should know before attempting the problems of crash course. Now we will discuss that problems.